Okay, well, using definition of the decibel and the knowledge of I naught, a couple of interesting problems that we can solve. One is pretty straightforward because we've already pretty much done it, but not for these numbers. We're going to find the decibel level of the sound if the intensity is 3 times 10 to the negative fifth watts per square centimeter. Okay, so, well, we just go to the formula. Decibel is 10 times the log of, 3 times 10 to the negative fifth watts per square centimeter divided by I naught, which is 10 to the negative 12 watts per square centimeter. That's equal to 10 times the log of, well, 3 times 10, well, 10 to the negative fifth. Those parentheses are in a weird place, aren't they? 10 to the watts per square centimeter divided by the watts per square centimeter separates out, it's essentially equal to 1, goes away. And we just end up with 3 times 10 to the fifth over 10 to the negative 12th. 10 to the negative fifth over 10 to the negative 12th is 10 to the what? Negative 5 minus negative 12, which is plus 7. So we have 10 times the log of 3 times 10 to the 7th watts per square centimeter. Now there's a property of logarithms that we can use. If you multiply, if you have the log of a product of two numbers, just kind of a flip side of a law of exponents. If you have a product of two numbers, you can do this. And I just said the watts per square centimeter goes away. And then without thinking, I wrote it down. Be careful here. Let's see what I'm doing. Okay. Now, again, the log of 3 times 10 to the 7th is the same as log of 3 plus the log of 10 to the 7th. And we can do this anytime we have a product of two or more numbers. As long as we don't have a plus in there any place, because it doesn't work if you're doing the sum of two numbers. You don't get a sum down here. You don't get a product down here. Just if you got a number times a number and you're doing the log of that, then it's a log of one number plus the log of the other. Okay, so I'm going to go ahead and do that. I'm going to tell you to go ahead and do that. We'll get more formal with these operations. But anyhow, that's 10 times the log of 3 plus 10 plus 10 times the quantity, log of 3 plus a log of 10 to the 7th. Well, log of 10 to the 7th is 7. What's a log of 3? If you do a short table of the log, and incidentally, this is the base 10 log. So anytime I write log without a base, it's the base 10 log. Should have actually explained that before, but anyhow. X is 0, the log of x is 0, is 1. If x is 1, 10. I hope I didn't do that. I've got to look back. I didn't. Okay. Log of 1 is 0, not the log of 0 is 1. Okay. Log of 10 is 1. Log of 100 is 2. We just take these three numbers and just kind of do a little schematic. We can see that the log grows more and more slowly. So if we want to estimate what the log of 3 is, if we wanted to put 3 into this table, what would the log of 3 be? It would be closer to 1 than it would be to 10 because of the way that curve is. You might be able to visualize that, might not. Then it's okay, you can use your calculator to do these. But the estimate I'm going to make here is that the log of 3 is about halfway between 0 and 10 because of the curvature of this thing. So this is just an estimate. You can take your calculator. And do the calculations, but log base 3 of 10, log base 10 of 3 is about 0.5. Add that to 0.7, we get 7.5. And we get 75. So sound with this intensity, I'm saying is about 75 decibels. And just illuminating how I do these estimates here. You don't have to be able to do them, but if you think about the curve, it's instructive to at least see if you can understand what I'm saying. Okay? That the log grows more and more slowly, so we get up to 0.5 more quickly than we get up to 1. Going from 0 to 0.5, x changes by less than it does in going from 0.5 to 1. Okay. Now, another problem we can solve, and we have the technique to do this. Find I if the decibel level is 54. Okay, so, well, that means that the decibel is 10 log of I over I naught, so that we know, well, let's write it out. Decibel is 10 times the log of I over I naught. If the decibel level is 54, we don't know I, but we do know I naught. Ten to the 12th, negative 12th watts per square centimeter. And now we want to solve for I. Well, we know how to solve logarithmic equations. Now there's a denominator here, but that denominator is inside the log, so we're not going to do anything with it for a while. We can rearrange this equation very easily. We can solve for log of I over 10 to the negative 12th watts per square centimeter. All we have to do is divide both sides by 10. We're going to see that the log of this quantity here is 5.4. Okay, well now, if we got the log of a quantity equals 5.4, we know how to express a logarithmic equation of this nature in exponential form. And this tells us then that I divided by 10 to the negative 12th watts per square centimeter equals 10 to the 5.4. Now remember that log means log base 10. So we can put a 10 in here anytime we want to if we want it to look right. We're going to go ahead and do that. Okay? If log base 10 of this equals this, then this equals 10 raised to this power. And from here, all we have to do is multiply both sides by the denominator, and we get I equals 10 to the 5.4 times 10 to the negative 12th, which equals 10 to the 5.4 minus 12, which equals 10 to the 6.6. Okay? And this is all in watts per square centimeter. And this is something you can plug into your calculator. Okay? And I'm going to say that this turns out to be between 3 and 4 million. Watts per square centimeter, if I'm thinking straight. And you can check that out easily enough yourself. You know, think in terms of this curve. Okay? So, we can solve an equation of this nature, and your homework's going to ask you to solve a few equations like this one and do a few of these. You don't have to do the estimates. Use your calculator.